We are going to solve some systems of equations, and we're going to start right here at the bottom. So I have a couple ideas. Here's one of them. I think that we should solve this using substitution. So here's the deal. If y equals all this stuff right here, then we can plug it in, well, for y right there. My other idea was we could solve this for y and then set this expression equal to the other expression. I'm not going to go there. Let's just go ahead and go straight into this right here. So all this goes in right there. So we have 2x plus y. Well, now we know that y is all the stuff right here. So it's x squared minus 6x plus 5. And that is equal to 5. And we'll simplify this a little bit, and then we'll go from there. So first of all, if we have a 5 here and a 5 here, if we subtracted 5 from both sides, they would cancel out, so those are gone. And we have x squared and 2 minus 6, negative 4x. That is equal to 0. This does not factor in the traditional way that we think of factoring. Sometimes we think of factoring as, oh, well, I'll do 2 sets of parentheses, and nope, not this time. Not going to do that. And here's why not. When I factor, and you should think this too, when I factor, I look for a greatest common factor first, and there is an x that I can factor from both of those terms. And so we have x minus 4. So we have 2 factors set equal to 0. If it doesn't equal 0, don't try to solve it by factoring, okay? I better make it equal 0. So we have x and x minus 4, and both of those equal 0. So obviously x equals 0 and x equals 4. So we have a couple answers here, but we're going to plug them back in and try to get the other solution, get the other part of the coordinate. Now, we're actually going to have 2 points of intersection. So when we're solving to find where they meet, sometimes they can meet at more than 1 point. This is a parabola and this is a line, and well, we'll sketch it in a minute. So what I'm going to do is plug in 0 in for x, and you know what, let's cheat just a little bit, and it's not cheating. Let's solve this for y. It'll make it a little bit easier. So negative 2x plus 5. There we go. So we have negative 2x plus 5. And now we're going to just plug in x there. So when we plug in 0 for x, we have y equals negative 2 times 0, getting it from there, plus 5. That means y equals 5. That means this. The coordinate 0, 5 is a point of intersection between this parabola and this line. Also, we have y equals negative 2x, x is 4, plus 5. And we do our little arithmetic, and we have negative 3. So 4, negative 3 is another one of those points. Okay? So I don't have much space, didn't leave too much room, but I'm going to make a table out of this. And when I do, that will help me get the points I need to graph it. So we have x, and we have x squared minus 6x plus 5. And we also have this one, which we solved right here. So we'll use negative 2x plus 5. There we go. Let's get some points going on. I'm going to start at negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. I'm almost out of room. No. Okay. Since I already know the answers, this is somewhat pointless, but I'm going to walk you through the process. And I'm going to cheat just a little bit and use a calculator. Let me get up and get one really fast. Let me show you something cool. Now let's not rely on this too much now. Don't get too crazy relying on this. But let me show you something. You grab your calculator. Yours looks different than mine, but that's okay. Same idea. And what I'm going to do is press y equals. And when I do, I'll clear out whatever I have in there. And I'm going to type that equation, the top one, x squared minus 6x plus 5. There's that. And then for the second equation, I'm going to go negative 2x plus 5. So negative 2x plus 5. And we have to solve it for y. And if I go to the table, then, well, this is what I have. Yours might look different. So if yours looks like mine, then what we need to do is set the table, second and table set. And we're going to set everything to auto. And just to give you a quick tour, this triangle is delta. It represents change. It's the Greek letter delta. So the delta table, it's going to change by 1 every time. If you go to the table, second and table, then you can scroll around, notice how the x value is changing by 1 every time. And you could fill in your table, which I'm not going to completely do. I am going to do a couple of them. I'm going to do this one, see it, 0, 5, and 5, so 0, 5, 5, and 4, negative 3, and negative 3. I'll do a few more. 0, negative 3, negative 4, and then 5, 3, 1, negative 1, negative 3. Okay, here's what's going on. We are plugging in these x values and getting out these y values. I'm going to use these to graph it so I can visualize it and see it. Okay, there are 3 methods going on here. We have solved it algebraically. Elimination, substitution, use whatever you like. We use substitution. We can use a table, which we did partially, and then we can graph it, which we're about to do as well. So we have 0, 5, 1, 2, 3, 4, 5, 1, 0, 1, 0, 2, negative 3, 3, negative 4, 4, negative 3, and I think we have enough points where we can draw what that is. It's a parabola. It's not the best looking parabola, but that's okay. It's something like that. And then we'll draw this line as well. And when we draw this line, we can plot those points if we like 0, 5. Or we could sketch that line right there. And so I'm actually going to plot these points instead, which is the same thing. So 1, 3, 1, 2, 1. There's that one, and then there's that one. And then when I connect these these dots, I have this line that should have been straight, but I don't have my ruler with me. There we go. And I have 2 points of intersection, so let's kind of visualize it. There's one of them. There's the other one, and notice that one of them is at 0, 5, and the other one is at 4, negative 3. Okay? Let's flip this over and do the next 2 or 3. The next 2, actually. Lucky us, there's only 2 more. We're going to do this one algebraically first. This one's a fun one. Okay, I have a couple ideas. First idea is this. Why don't we isolate a variable? Let's get one of the variables by itself. And when we do that, we can just kind of bring this over here. I'm going to solve for x because it would just be easy. So x equals, move that y over, and we have 5 plus y. So we've just solved for x. And sorry, I didn't mean to bump the camera there. You saw it shaking like that. My bad. Anyway, x equals 5 plus y. That's what we have. And we can substitute this expression in the place of x right there. So let's do it. So instead of x, we have 5 plus y. So 5 plus y times y plus 6 equals 0. And then we solve that. Well, how in the world do you solve it? Well, let's clean it up first. So we have 5 times y. We're distributing here, so 5y plus y squared plus 6. That's equal to 0. And, oh my goodness, this is out of order. Let's put it in descending order by exponent. So this one comes first. I hope you notice it's quadratic. Then the 5y. Then the 6. That's equal to 0. And when we do that, now we have a quadratic and it equals 0. Do not solve a quadratic until it equals 0. And this one does. So now we can solve it. We can factor. Well, don't solve a quadratic by factoring unless it equals 0. 2 numbers multiply to give me 6. They add to give me 5. It must be 2 and 3. They're both positive. I say they're positive, but actually when I get my solutions, they are negative. So we're going to have y plus 2 equals 0. You can skip this step if you like. Y equals negative 2. Then you're going to have y plus 3 equals 0, so you're going to have y equals negative 3. Okay. So we are going to plug a negative 2 in for y to get our x value. And when we do, we'll crank out a couple points of intersection. This one's actually an interesting graph. And I'm going to do a table and a graph on this one. I'm going to make it very quick though. Let's see. I have x equals 5 plus negative 2. So x equals 3. Final answer is 3, negative 2. That's one of my points of intersection. I'm going to box it in red. Put it in a red box. You can rent it for $1. It's a great joke. All right, let's do another one. Let's do x equals 5 plus negative 3. So x equals 2. So where am I? 2. Lost my place. Negative 3 is a coordinate. Here's the other one. So we found a y value. We plugged it in and got an x. So we have 2 points of intersection. So let's come over here and make a table. X, and then, whoa, hold on now. If we're going to make a table, then what we really need to do is solve these for y. I solved it for the wrong thing. That's okay. I'm going to do that in green. I can do this very quickly in green. So x, y equals negative 6. I hope you notice what I'm doing. Just doodling here. Taking this, solving for y. Y equals negative 6 over x. We would divide by x. There we go. So x, negative 6 over x. And then we need to solve this one for y. I'm going to keep doodling. So if we have x, let's switch to doodle green. X equals 5 plus y, and I want to solve it for y. That's the most practical way to graph. Then I'll have y equals x minus 5. So we have x minus 5. And here's what we're going to do. We're going to make a table. On your homework, you need to solve using any two methods. That can be a graph and a table.